Welcome to Easy Alim Learning Simplified. My name is Ruth, and today we are going to be looking at Organic Chemistry 1. So initially we talked about alkenes and their nomenclature. So for this lesson, we are going to be looking at the rules for naming alkenes, and then we will look at some practice compounds of alkenes and how we name them. So first, you start with the first rule of naming alkenes. So the first thing we always do is identify the longest carbon chain. So that's where we usually get the parent chain or the parent name or root name as we called it in the previous class in alkanes. And then after identified the longest chain, the carbon atoms in the chain are numbered such that the carbon atoms joined by the double bonds gets the lowest possible number. So first, let us identify the longest chain in this this compound. So if you look at the longest chain, it needs to have the double bond must be part of the longest chain. So you can see the longest chain in this question is the one that is in red one. There are two alternatives, but it's the same. You can see the longest chain is this red one. Let us not forget there's a carbon here and 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 the outer one. Same case to this is the same, but numbering is different. So we are going to discuss which is going to be the right way to number. So we say that the atoms in the chain are numbered such that the carbon atoms joined by the double bond get the lowest number possible. So the double bond should be given the lowest number. That carbon should have the lowest number. So if you were to name this first way where 1, 2, 3, 4, 5, 6, 7, 8, it means the carbon that has the double bond is carbon number 8 and the other is carbon number 7. If we were to name the other way around, it would be 1, 2, 3, 4, 5, 6, 7, 8. So the two carbons that are holding the double bond would be in carbon number 1 and carbon number 2. So if you were to pick these two, this would be the right alternative because it's giving these carbon atoms the lowest number, which is going to be number 1 and number 2. So let's look at another example. So if you look at this compound, first of all, we identify the longest chain. We see that the longest chain is the one that has a double bond. So you see where the double bond is, you can start counting. So we have 1, 2, 3, 4, 5. We can go also 1, 2, 3, 4, 5. We can go 1, 2, 3, 4, 5. Either way we go continuously, we have 5. The longest chain has 5 carbons. So you pick the easiest one, which is the one that is this one. Anything outside the longest chain is a branch. After that, we start numbering. So we can number from 1, 2, 3, 4, 5, or the other way around 1, 2, 3, 4, 5. If you were to pick the first method of numbering, our double bond would be in carbon number 3. If we pick the other side, the first carbon bonding the double bond would be in carbon number 2. So the second one is the one that we are picking, is the one that we pick. So you start counting from this direction. 1, 2, 3, 4, 5. The upper one, we are not picking this one. So let's look at this other example. So first you identify the longest chain. So let's see continuous chains that we have. So we have 1, 2, 3, 4, 5, 6, 7. We can also go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 1, 2, 3, 4, 5, 6, 7. So either way you go, you're still going to get 7. So we pick the easiest one. So this will be our longest chain. Anything outside it is a branch. So when we start numbering, let's start with this side. It's going to be 1, 2, 3, 4, 5, 6, 7. If we start from the other side, bottom will be 1, 2, 3, 4, 5, 6, 7. So the double bond, if we number it from the upper side, you notice the first carbon that is bonding that has the double bond will be in carbon number 3. If we count 8 from the bottom side, you notice the first carbon having the double bond is in carbon number 4. So we will prefer the one that is having carbon number 3 to the one that is having carbon number 4. So we will scrape off the lower one and we are going to use the upper one to number. Finally, so you can see this is a skeletal compound. So when we identify the longest chain, it's just going to be very easy because it's just there. There is no branch in this question. So there's a carbon here, number 2, number 3, number 4, number 5, number 6, number 7. So this is an hexene with the branches at carbon number 3 and another carbon number 4. So yeah. So when we start numbering, we are going to number from this side, not the other way around. So that's how, first of all, you notice in alkenes we give preferential when we are numbering. The double bond is given the preferential. We do not consider the branches first. We consider where the double bond is. The third rule is that the position of the substituent group is indicated by showing the position of the carbon atom in which they are attached. So after now giving the double bond the preferential when it comes to numbering, after that now we give the positions of the substituent group. So in this case we repeat the process. So 1, 2, 3, 4, 5. So this is going to be the longest chain. So we have a branch here. This branch is known as ethyl. And we have a branch here called methyl. We said when we are numbering, we prefer the double bond. So we are going to number from this side 1, 2, 3, 4, 5. Because this side is going to give the double bond, which is in carbon number 2, the least number. So that tells you our ethyl group is in carbon number 3 and our methyl is in carbon number 4. So when we are naming, we will identify. And remember what we said, when you have more than one, you name alphabetically. You notice ethyl comes before methyl. So our compound will be, it will be 2-ethyl. And then you show where the methyl is, which is in carbon number 4. And then our parent name has 5 carbons. That tells you is a pentene. But now when we write for alkenes, we identify where the double bond is. In this case, it's in carbon number 2. So it is pent, then 2, then in. Let's do another example. So next we identify the longest chain in this question. So this is going to be our longest chain. We did this in the previous question. And then we choose the numbering. So when we are numbering, we are going to prefer this side because it gives the carbon that has a double bond number 3. So this is 1, 2, 3, 4, 5, 6, 7, which is different from when we choose the upper one, which is going to be 1, 2, 3, 4. You see it's in number 4. So we want to pick the one that the first carbon is in number 3. Anything outside, this is an ethyl, this is a methyl, these are branches, this is a methyl, and then this one is an ethyl. So we have 2 ethyls at the same carbon number 5 and a methyl at carbon number 3 and another methyl at carbon number 2. So when you start naming, we name alphabetically. You notice we have the similar type of branches. So we use the words di, tri, tetra, and so forth to represent, like this one shows there are 2, these are 3, and these are 4. So in this case, since ethyls are 2, you use di, and you start with ethyl because it's in the first letter in the alphabet in comparison to M. So it's going to be the first ethyl is in carbon number 5, the second ethyl is still in carbon number 5, but since they are 2, we'll use now the word di. So it becomes diethyl. And then remember we have other branches and they are similar as well. So we have another methyl at carbon number 3. So we start with carbon number 2 because it's the lowest, and then another one at carbon number 3 as you can see. And since there are 2, we still use di. and they are called methyl. And then the parent name has 7 carbons, which tells us that is heptene. So you write hep, and then we show where the double bond is. It starts in the carbon number 3. So it is hept3 ene. So that's how we name that. So let's look at this other example. So we identify the longest chain first. So remember, the longest chain has to have the double bond. So we can count 1, 2, 3, 4, 5. We can count also as 1, 2, 3, 4, 5, 6. We have also 1, 2, 3, 4, 5. And we have 1, 2, 3, 4, 5, 6. So we can pick this one. This will be our longest chain because it has the largest number of carbon continuously. So we have an ethyl here. We have a methyl. These are branches. And we have also another methyl. So the next thing we do is start numbering. We need to give the double bond the least number possible. So you start numbering 1, 2, 3, 4, 5, 6, so that this gives us the double bond is in carbon number 1. So when we start naming, we start with ethyl because alphabetically it begins. So ethyl there's one ethyl at carbon number 3, so it's going to be 3 ethyl. And then remember there are 2 methyls, one at carbon number 2, the other one at carbon number 4. So you indicate that, so it's 2, 4, and there are how many? There are 2. Remember we used the word di, so it's dimethyl. And the parent name has 6 carbons. That tells you it's hexene. So you write X and then show where the double bond is, and it starts from carbon number 1. So X1 in. So our final example is this, and you can see this is a skeletal. So first we identify the longest chain, and it needs to have the double bond. So you can start from 1, 2, 3, 4, 5, 6, 7, 8. That's the longest. So whatever I circle is the longest chain with 8 carbons. And then when you start numbering, you start from this side so that you can give this double bond and lowest number. So it will be 1, 2, 3, 4, 5, 6, 7, 8. So we have, this is a methyl branch. This is also a methyl branch. So we have one methyl at carbon number 2, the other one at carbon number 5. So it's going to be 2, 5 since they are similar. And since they are 2, we call them dimethyl. The parent name has 8 carbons, so it is oct. We show where the double bond is, which is number 2, so it's oct2 in. So that's how you name it. So there also are cases where we have more than one double bond. So when you have more than one double bond, make sure when you are giving the position of the double bond, you give them the least number possible. And in the case where we are giving the position of the double bond, we introduce a die. So that's the final rule. For example, you are given this compound. So remember the double bonds needs to be in the longest chain. So our longest chain will start from here. This carbon number 2, number 3, number 4, number 5, number 6. We didn't start from here because the double bond needs to be in the longest chain. So this is going to be our longest chain. This. So anything outside is a branch. So we have a bromo and we have a methyl. So we can start naming from either side. In this case, if we start naming from either side, the double bond one is going to be in carbon number 1. The other one is in carbon number 6. So what we do, since the direction is not going to change for the double bond, we ensure we give the bromine the least number possible. So you start from this side as 1, 2, 3, 4, 5, 6. That way, yes, we are preferring the double bonds, but also we are giving bromine a preferential since the double bonds do not change their position. The halogen comes first before the alkyl groups. So when we name this compound, we start with the branches and we start with bromo because it comes first alphabetically. So it is in carbon number 3, so it becomes 3-bromo. And then we go to methyl number 5-methyl. And then the parent name is hexene, but now we write X, but we have 2 double bonds. So the first double bond is in carbon number 1, the other one is in carbon number 5, and we call it diene. So you notice we put a di on the in to show that we have 2 double bonds. So finally, the last example. So we have this compound also, it's skeletal. So let's identify the longest chain. We'll start from here 1, 2, 3, 4, 5. So from here, we are going to go here. We're not going to go the lower one. Because if we go for the lower one, this compound here is going to be confusing. We do not have a branch that looks like this. So in high school, in the lower values, so this is going to be 5, then 6, then 7. So that this is going to be our longest chain. So this is going to be a branch, methyl, and we have ethyl. Ethyl because you can see 2 carbons. So this is, when you start now numbering, you number from this side because it gives the branches the least number. So it's 1, 2, 3, 4, 5, 6, 7. So this is going to be, the ethyl begins in naming because of the list, the alphabetic. So it's 5-ethyl. And then we have a methyl at number 6, 6-methyl. The parent name has 7 carbons, so it tells you that it's heptene, so it's hept. And then we show the double bonds where they are. We have first double bond at carbon number 2. We have the second at carbon number 4. And there are 2 of them, so we call them diene. So that's how we usually name alkenes. It's not that complicated, just go slowly, you're going to understand. So that brings us to the end in terms of naming alkenes. So in the next lesson, we are going to see how some of the properties of alkenes. So see you in the next lesson.